Okay, so we did this last time. So I'm going to begin today's class by, again, just a little review of what we've done so far. So which of the following cells aids in the immune response? Okay, it's the Langerhans cells. Remember, Merkel cells were touch or pressure receptors. Okay, so again, whenever you know a cell, you have to know its function. Very, very important. So where you had that slide on the different cells, good idea is to write the functions there itself. Langerhans cell is the one which takes part in immune response. It's phagocytic. Melanocytes, they are responsible for protecting the nucleus of the cell, and they happen to also give skin its color. The Paxinian corpuscle is a touch receptor which is present in the dermis. These three were epidermal cells, okay? Here, another question. Who has more melanocytes? Okay, C is the correct answer. Remember, I said we all have approximately the same number of melanocytes. It is the amount of melanin which is present or produced by those melanocytes which gives the skin its color. Okay, so a dark-skinned individual and a light-skinned individual, we have the same number of melanocytes. In fact, when you tan, your melanocytes don't increase in number. It's only the amount of melanin that is produced by each melanocyte which increases, okay? So we all really have the same relative number. A light-skinned individual just produces less melanin. Dark-skinned individual produces more melanin. And this was basically because of where they lived. So people who lived close to the equator were darker skinned because, you need sun's rays are really strong there and need to produce more melanin. Those who lived at the poles or, far away from the equator, not as much was needed, so they produced less. Now let's look at skin color pigments and some other clinical applications that we do with, which has to do with the skin color. So melanin is one of the pigments, carotene is another pigment, and hemoglobin is the third pigment. Hemoglobin, which is flowing in the, the blood, which carries red blood cells, and red blood cells have the hemoglobin pigment. So these are the three pigments. Carotene is kind of like a yellow pigment, usually seen in vegetables which are orangish in color. Carrots is a good example of where you get carotene. Red peppers is another one where you get carotene. Some people have more carotene in their as part of their pigment color, so then they have a little yellowish tinge to their skin. The pinkness of the color is based because of the blood flowing, and in the blood it's the hemoglobin pigment which is really giving you the skin color. And then, of course, it's the melanin, which gives you the different hues, depending on whether you have eumelanin or pheomelanin. Remember, I told you the different types of melanin. One was a little brownish, one was a little reddish. And then the amount of melanin that you have gives you, you have different colors like olive skinned, and then some people are really pale, some people are who are more red, that kind. So that's that. So these are the three important skin pigments: melanin, carotene, and hemoglobin. And some clinical observations. You've seen people with freckles. This is areas where melanin pigment is concentrated. So freckles is just an area where the melanin pigment is concentrated. So this is concentration of melanin pigment. Then albinism, there's albinos, you call them, who are really pale looking, even their eyelashes are, golden color, they lack the pigment. And here they don't have any pigment because of this enzyme called tyrosinase. Tyrosine is a protein which is used in the production of melanin, and tyrosinase is the enzyme which kind of helps with that. And so they don't have this enzyme, so they are unable to make the melanin pigment. So that's why they're really kind of very, very pale, and they look, the eyelash also kind of looks, blonde. They kind of look like that. Then we did a vitiligo or vitiligo. I told you this is an autoimmune condition where the immune system is attacking its own body. Other examples of autoimmune diseases are ones that you might know are lupus and multiple sclerosis. So this is similar to that, in that it's an autoimmune disease where there is a loss of melanocytes in the skin. So the areas become patchily depigmented. And I showed you an example, of this vitiligo earlier. I showed you a picture of that. It's not contagious. It's not like a fungal disease or anything, just tends to sort of spread slowly and seems to run in families. Then we have certain terms which we use with skin conditions. One is if there is a bluish discoloration of the skin or mucous membrane. So this is a bluish discoloration of the skin or mucous membrane. What do I mean by mucous membrane is, for example, like your lips, your tongue, your gums, and even the nails. Look at this child's nails also look blue. So this is known as cyanosis, and usually seen whenever there is a cardiac or a respiratory problem. So the oxygenation is not good. So the amount of deoxygenated blood is more. So the levels of oxygen in the blood are low. And so that means it's more deoxygenated, and that gives rise to this bluish discoloration. So whenever anyone is in respiratory distress, that means, or they have any cardiovascular problem, you usually will find that if you look around the mouth, the lips, if you look in the sclera of the eye, if you look at the skin, nails, you'll find that all looks very blue. Okay, so this is cyanosis. Another condition is called erythema. This is where there is redness of the skin. So there's an increased blood flow to that area. It could be harmless, like, for example, when someone blushes, the air around the cheek area, that's an emotional response. So there's more blood supply going to that area, so that area becomes flushed, which is erythema. Or like you go out in the sun and you get a little sunburnt, you might have a little redness to that area. So this boy's face is showing a little erythema, or at the beginning of inflammation, or if you've ever had a boil or something, you can see the area around the boil looks very pink and looks much dark, brighter in color, bright red compared to the rest of the area. That's because of more blood flow to that area. Okay, so that is erythema. Jaundice is a condition where you can see, as here again, discoloration of the mucous membrane and the skin. And look at this, it's yellow in color. So this is yellow. This cyanosis was blue. Jaundice is yellow discoloration of skin and mucous membrane. So skin and mucous membrane. So again, same areas like the sclera of the eye, the tongue, the gums, the lips. And this is because of a pigment which is called bilirubin. This pigment is produced, or rather produced and then broken down and recycled in the liver. So whenever there is any liver problem where it cannot do its job properly, this pigment builds up, its byproducts build up under the skin, and that gives rise to this yellowish discoloration. Okay, so this is called jaundice.
Why are babies?
Babies are jaundiced because, and that is called physiological jaundice. When babies are born, their red blood cells, they still have what is called fetal hemoglobin in them. They don't have adult hemoglobin. They have a lot more red blood cells. So there is massive red cell death, actually. So the cells are beginning to die and they're beginning to acquire adult hemoglobin. The liver is still immature, so it's not able to take care of, so when red cells break, that hemoglobin pigment actually helps in this whole bilirubin cycle. So it's not able to take care of it, which is why the bilirubin pigment kind of builds up. And then that is kind of flushed out, the liver matures fast enough and that's flushed out. So that's why it's called physiological jaundice, in the sense it's one of the normal processes of just after birth.
I thought is it cured by UV light?
If the child has any other problem or is severely jaundiced, then you put them under ultraviolet light so that the bilirubin pigment can be broken down and then flushed out. Yeah. But you might have a child who's born normally, taken home, and you can still see them jaundiced, and you don't need to do anything. You just put them out in the sunlight or don't do anything. It'll go off on its own. Okay. Okay, so here I'm just going back and just pushing some questions in just to get you to think of some of the things you did. Remember we did epidermis and dermis. So here, which layer is responsible for the characteristic unique fingerprints? So this kind of tells you whenever anything is mentioned, anything special about an area, and you read about it, automatically, immediately highlight and maybe make a little notation on the side so that you remember, okay? Yes, it is the papillary layer of the dermis. Remember, the fingerprints was from the dermis, the papillary layer of the dermis. If you remember, there were projections in the papillary layer. That's papillary. That's why those projections are called papilla. And then this raised the dermis over it. Papilla just means projection. So that part of the dermis was known as a dermal ridge. And this dermal ridge, because the epidermis sits on top of the dermis, the epidermis also gets raised, and this is called the epidermal ridge. And together these are called friction ridges, which you can see on your hands, your palms and your soles, right? You can see these whorls and all that I described earlier. And this is because of the papillary layer, because it projects like that, and that's what gives rise to the fingerprints. Now here let's look at accessory structures of the skin. So again, whenever you're looking at these, you must know, it's always good to make a little note, okay, which of these structures are accessory, which are true skin. So skin consists only of epidermis and hypodermis. Epidermis and dermis. Hypodermis is not really a true part of skin, we just include it. And the skin then has all these helping structures, which we call accessory structures. There are some structures where, like hair, for example, then you have these oil glands, which are also known as sebaceous glands. Then we have sweat glands, which are also called sudoriferous glands. And then nails. So these accessory organs are derivatives of the epidermis. You will see how the epidermis goes down and it actually forms these accessory organs, which is why I don't have erector pylorem in this list, because it is not an epidermal derivative. It is still found in the dermis, but it's a separate structure by itself. It's a muscle there. And the way these structures are formed is that the epidermis goes in, and you'll see, for example, if this is the epidermis, the many-layered epidermis, it'll go in and you can see it'll form the hair follicle. Some areas it goes in and then it'll form a gland, and this part of it will be the duct. In other areas it'll go in and form a different type of gland. Okay, and the nails, of course, are, in the nail you have hard keratin, so again it's an epidermal derivative. So let's look at each of these structures in turn. So we look at hair, sebaceous gland, and now here we look at the erector pylorem muscle, which is seen with hair and sebaceous gland. Now hair is hard keratin. on the surface of your skin, like your thin skin and thick skin, you can peel it off, which you can scratch off. That is soft keratin. But in your nails and hair, it is hard keratin because you can't kind of peel them off easily. You can't peel your nail off easily, on the surface. Okay, so this is hard keratin. And this again has different color. We all have, our hair color is different. So again, based on what kind of melanin pigment is present and how much of it is present and what ratio you have pheomelanin and eumelanin. And this can change because, some people are, when they're born, they may be blonde, and then as they sort of grow up, they kind of tend to get a little bit, the hair color tends to get a little darker.
What about when they get older still and it gets lighter?
Yeah, when they get older, then
is that loss of melanin?
Yes, there is, and the air spaces go in between, and that gives rise to the gray hair, and there's loss of melanin, which is why your hair begins to gray.
So you do lose melanin?
Yes, you do lose melanin when you grow older. The parts that you see of hair is the shaft is this portion, which is the visible part, this part which you can see on the surface, that is called the shaft. And if you take a cross section of this shaft, so if I take a cross section like this, I will see a round structure, okay? The center of that round structure is known as the medulla. The medulla is always the center. So that's a good thing to remember because when you do ANP2, you have many things which have a medulla and a cortex. So this is the medulla, which is the central area. This surrounding it area, this part is called the cortex. And over the cortex, you have thin cells which kind of lay flat one on top of the other, almost like shingles on a roof, and that is known as cuticle. So I'm going to draw this again. So here's the medulla, here's the cortex, and these cells lie one on top of each other like this. Can you see? This is what is called cuticle. So actually when you brush your hair the other way, when you tease your hair, what you're doing is you're really getting these out, and that's why your hair looks kind of pokey and different. When you use conditioners, what the conditioners do is they make these cells lie one over each other this well, and that's why your hair looks really smooth. Okay, so that's how they act. This cuticle is really smoothened out. That's what even ironing your hair does. It makes the cuticle absolutely smooth. Vellus hair is very, very fine hair. Usually children are born with it. And terminal hair is the hair which is really coarse. It's the kind of hair that you find on your scalp. So that was the shaft, which is the part that is visible and above the surface. And then the rest of the hair goes into the dermis. So this part below is known as the root. And you can see this when it goes down into the dermis. There's a little bit of a swelling present here, which is called the bulb. And this hair here is actually surrounded. You can see here, this is the epidermis. Notice how the epidermis comes down and it actually surrounds this whole root like this. Can you see this? Right? That is what is called a hair follicle. And this part of the hair follicle is swollen here, you can see at the end where it's the bulb. So this here is called the epidermal sheath because it comes from the epidermis. So can you see how the epidermis is dipping down, surrounding the hair and then going back up? So this is called the epidermal sheath. And then on the outside, because this is all dermis, what the dermis does is the dermis also kind of gets a little concentrated around the lower end of this root where it's called the dermal sheath. Have you followed that? Okay, so if I was to take a section from this area, right from here, you can understand the outermost layer would be like a dermal sheath, right? If I say that's the dermal sheath, then I will have an epidermal sheath. So if I draw this like this, that will be the epidermal sheath. And then I will have the cuticle and then the cortex and the medulla. Have you followed? Okay. Next to the hair follicle, you have glands which are known as sebaceous glands or also called oil glands. And again, look at this picture. You can see how we said all of these were epidermal derivatives. Can you see this epidermis here? It's gone in and now it's formed a gland. Can you see that here? So this part here is the sebaceous gland. It's made up of cells which are, when you look at them under the microscope, they look large, very lightly staining cells. They produce oily substance. That's why they are known as oil glands. And the substance they produce is known as sebum. So it comes from sebaceous, sebum. So since it's oily, it's poured into, can you see it's associated with a hair follicle and the shaft. So it pours it into this and it helps to lubricate, which is why you find that after, when you wash your hair, and if you haven't washed your hair for 3-4 days, after some time your hair begins to feel oily. Right? Because you haven't kind of removed the oils. And that's good for you because it helps to lubricate the oil. These sebaceous glands also, the sebum is also bactericidal. It prevents the growth of bacteria. So it has a substance in it which will prevent that. Because of the film of oil that it produces, that oil also goes on the surface and lines the surface of the skin. So it prevents water loss. So if you remember, one of the functions of skin was to conserve water or prevent water loss. So this is how it does that. So not only does it lubricate the hair, it has bactericidal properties, prevents growth of bacteria and coats the surface of the skin with oil. So it prevents water from evaporating, so conserves water and hence helps to prevent water loss. Now this gland, its cells are, like I said, its cells are, suppose I just draw a sebaceous gland, its cells are like this. Large cells, very faintly staining with nuclei, which you can see, they look like little sponge balls. These cells, when they pour out the sebum, actually the cell ruptures. So their mode of secretion is what is known as holocrine. So the entire cell actually ruptures and the cell below will then divide and give rise to new cells. Now they pour their secretions here into this hair shaft and into the follicle. Sometimes this mouth into the sebaceous gland, that area can get blocked. So if it gets blocked, that whole gland will keep on producing, but it cannot pour out its secretion. And that's what you have when you call whiteheads. You have these little whiteheads. If there's dirt inside it, then it's known as a blackhead. Sometimes, however, a sebaceous gland can get infected. And when it gets infected, you have a little inflammation in that area. You might even find a little pus. And that's what leads to acne. Testosterone has an effect on the sebaceous gland. It tends to kind of stimulate them, which is why during growing periods, young boys, they tend to have acne during that time because, testosterone levels increase at that point. So when they make these oil glands secrete more, what happens? Oil kind of coats the surface of your face, and then oil would naturally attract anything. Things will stick to it. So dirt can stick to it, bacteria can stick to it, so that area is dirty and has bacteria. You can see how infection can spread. So whenever there is acne, whenever someone suffers from severe acne, usually they have a overstimulation of these sebaceous glands. Okay? Which is why you need to wash your face. I mean, you can't let dirt settle. You don't want to wash it too much also, because then you remove all the oils which are protective. Then let's look at this muscle which is associated with the hair and with sebaceous gland and has something to do directly with them. And this muscle is called erector pylorem or erector pili.
Is that with every hair follicle?
Yes, has erector pylorem muscle.
When you look at it, you don't always...
No, you don't. They don't draw it. But yes, all hair follicles will have erector pylorem attached. And you'll find muscle bundles going from one to the other. So you have one muscle and might send bundles to the hair follicles close to it. It's a smooth muscle. Very important to remember. Smooth muscle. And remember when we did tissues, we said muscle, if it was smooth muscle or cardiac muscle, it was supplied by the autonomic nervous system. If it was skeletal muscle, it was supplied by what was called the somatic nervous system. So this is smooth muscle, and its nerve supply is the sympathetic nervous system. So again, important. Whenever you have such things, it's always important to take note of it. And this can tell you its function. You all know the sympathetic nervous system also supplies sweat glands. It also happens to supply sweat glands. And think of what happens when you feel scared. You begin to sweat a lot, and your hair also begins to stand up. And sympathetic also actually supplies blood vessels, so it constricts blood vessels. You remember one of the functions of skin was to maintain body temperature, right? When it was very hot, we sweat a lot, our skin looks flushed. When it's cold, we don't sweat as much, our skin is pale in comparison. And that's how the skin maintains body temperatures, through sweat glands and blood vessels, right? And that is supplied by the sympathetic nervous system. So, while we're doing this, I thought I'd mention that as well. Now, how does this erector pylorum help? I mean, why is it close to a hair follicle and the sebaceous gland? When it contracts, what it does is it shortens. So when it contracts, it shortens. It becomes much shorter. So it pulls down from here. So this part, sort of that, at that point where it's attached to the surface of the skin, that dips a little, which is why you have those goosebumps, okay? And what it does is it pulls on this hair follicle and it straightens the hair follicle. The hair follicles are not in your body, they are at an angle. All these shafts are at an angle like that. So now when it pulls, it straightens the hair follicle, so the hair now becomes erect like this. So hair stands up straight. In us, it's not much of a, and the way the hair stands up straight, it helps to trap heat over there. In us, that's not as much of a function. I mean, we don't rely on our hair to stand erect to trap heat, but this is something that has come evolutionarily down from the animals. The other thing that this muscle does is that when it contracts, it squeezes the sebaceous gland. See, this gland is lying between the erector pylorum and the hair. Can you see it's lying at that angle? So when it contracts, it squeezes the sebaceous gland so that it helps to pour the sebum into the hair follicle, and so that way it will help to lubricate the hair. Okay? So that's the function of this muscle. So it causes, because at one end it pulls down on the epidermis, it leads to goosebumps. At the other end, it makes the hair stand erect, and it squeezes the sebaceous gland, helping to pour the sebum into the shaft and lubricate the hair. And with the sebum, again, the bactericidal, more the sebum produced, the better the bactericidal action of skin would be.
What causes it to contract when it's wanting to squeeze the sebaceous glands? What causes that? I mean, does it just happen?
The sympathetic, it has to be a stimulation of the sympathetic nervous system. Yes.
But does it do it separately beyond? I mean,
yes, it can. It doesn't have to do it only when the hair is standing erect. That's what you are asking. Yes. This is a normal body function. The sympathetic nervous system will, stimulate the muscle, and it will squeeze the gland, and hair, it will lubricate it. At times when you need the hair to stand up, then it will do that as well as squeeze the gland. Yes. They don't always have to act together. That's what you're asking. Yes. Yeah.
Act together.
So here again, a little look. So here you can see, here is the erector pylorum, here is the sebaceous gland, here is the hair and the root, and this lower end of the hair is called the bulb. And you can see when it straightens out, it will squeeze it and pour into that. And it doesn't always have to make, the gland doesn't have to be stimulated and the hair becoming straight. They can occur independent of each other. And let's look at a little bit at this lower end of the hair follicle and this area here. So where this hair, when it comes down, remember I said this area becomes enlarged and is known as the hair bulb. So this part here is called the hair bulb. And here you will notice at the hair bulb there is a kind of, again, a little sort of projection which is placed here. Can you see this area here? There's a little projection here. This part here, that little projection which you see, this area, this projection inside is known as the hair papilla. Again, papilla, can you see, means projection, like a pointed thing. And here is the epidermis which has come down, which has enveloped it. So I'm going back. So what I'm showing you here is the papilla. So this connective tissue papilla, can you see this? At this lower end, at the bulb, there is a little projection of the dermis which is called the papilla, where blood vessels are present. And here you can see the epidermis is surrounding it. So here, this first layer here, look at the epidermis which surrounds it, and then over here you can see that the dermis is surrounding it on the outside. So this is called the dermal root sheath. This is called the epidermal root sheath. You don't have to worry yourself about something called the glassy membrane, which is the area between the dermal and the epidermal root sheath is just surrounding, it's just a different zone between, just separating the two. Here you can see this part is the medulla, and this area here is the cortex, and this on the outside, this white line would be the cuticle. This papilla is important because this is the area where you have blood vessels which will supply this part of the hair. And this is the first layer, remember, stratum basale. That stratum basale is this area here, and that's how you can see these melanocytes. So these all, what you're looking at are melanocytes. So this part of that stratum basale, what is the function of stratum basale? Called germinativum. It is mitotically active, right? So this part is known as the hair matrix. That means this is where cells are beginning to divide. And what they will do is, as they keep dividing, they will push more cells. So they'll keep pushing and the hair will keep growing up. And that's how the hair keeps getting pushed. That's how the hair keeps getting pushed from below. As these cells keep getting added, it gets pushed up, and that's how your hair increases in length. Okay, so you cut it, it keeps getting pushed from below. So when you remove hair, if you remove the matrix, then obviously you've kind of that hair will not grow at that point if the matrix is removed. Normally when you pluck your hair, the matrix is left behind, and that's how hair follicles can regenerate.
So what is it for people that are bald?
Yes, so I'm coming to that. So in people, now these hair follicles are not continuously active throughout your life. They go through periods of rest, and then they go through periods of activity. In some people, and it could be different things. There could be a case where there is an autoimmune condition where the hair follicles are attacked and they are permanently at rest, so they are inactive. So then the person loses hair at that point. You have bald spots over there. So that is known as alopecia areata. So alopecia is a term which means baldness. And this is when the hair follicles are inactive. Alopecia areata is a condition where the hair follicles have been attacked by an autoimmune by the immune system, so it's an autoimmune disease. So you have bald patches at different parts in your scalp. It could be on your body also. In men, they have what is called male pattern baldness. In men, what happens is that the testosterone, a byproduct of the testosterone called DHT, it tends to make these hair follicles inactive and usually kind of affects the crown of the head more than the sides of the head. And it is kind of transmitted in families. It's a hereditary condition. So these people, men, are bald here, right on the crown of the head, but they have hair growing on the sides because that byproduct tends to it has a predilection for the crown of the head. So it makes the hair follicles inactive at that. So whatever treatment they take is done so that you kind of negate the effects of that DHT, and you make the hair follicles come back and, stimulate them. So they have to take it all through. They have to keep continuing to take that medication, or else they get hair transplants. Okay? So that is alopecia. Baldness could be of different types. It could be autoimmune. It could be a male pattern baldness, or sometimes, just you're a little stressed out. The hair follicles go off. There may be times you might have noticed where you lose more hair than at other times, and, the hair doesn't seem to grow back as fast. Again, stress tends to affect hair follicles, okay? The opposite of alopecia is where you have more hair than normal, and that is known as hirsutism. Usually we never refer to a male as being hirsute because you expect them to have hair. I mean, it's just that some men are more hairy than others. But in women, hirsutism is because of increased androgen production. In women also tend to produce some testosterone. When the testosterone levels in women tends to rise more than normal, then they that stimulates the hair follicles, and so they have hair on, you know, a lot more body hair, may have hair on the upper lips and other areas, and that's known as hirsutism, okay? So there's overactive hair follicles in them. Let's look at sweat glands. These are also another name for sweat glands is sudoriferous glands. So again, whenever you look at a PowerPoint, you see some names like this, it's a good idea to kind of always note that down. There are two types of sweat glands. One is called an eccrine sweat gland, which does not necessarily open into a hair follicle. It opens separately on the surface of the skin. And there's another kind of sweat gland called an apocrine sweat gland, which is usually, these are usually seen in the pubic areas, in the axilla or armpit. They tend to open into hair follicles. If you notice, it opens into hair follicles. The eccrine sweat glands produce a very watery kind of secretion. The apocrine sweat glands, their secretion is a little thicker, more milky. And it's because of that, it's present in the axilla and pubic region. It doesn't have an odor normally. The common body odor that you have is because of bacterial growth. See, it's present in these areas which are covered most of the time. So if if someone is not very hygienic, the sweat collects over there, and then bacteria tend to grow in that, and that's what really gives rise to the body odor. Now, the pH is acidic. It also, like sebaceous, like sebum, has antibacterial properties. And just by the process of sweating, it helps to remove the wastes. If you remember, that was one of the functions of skin. I also told you that sweat glands were also under the sympathetic nervous system. So that's why I have it here, sympathetic nervous system controlled. And then in certain areas of the body, you have what are called modified sweat glands. You have one type known as the ceruminous glands. These are modified sweat glands which are seen in the external ear canal or external auditory canal. And they produce, mixed with the sebaceous gland secretion, these modified sweat glands produce wax. Your wax in your ear is called cerumen. The correct term for wax is cerumen. That's why you get ceruminous glands. So modified sweat glands seen in the external ear canal. And cerumen is this waxy substance which is produced by these glands, and it's mixed with the sebum which is produced by the neighboring sebaceous glands. Mammary glands are also modified sweat glands present in the superficial area of your thorax. Whenever someone has increased, there are some people who sweat a lot more than others, okay? Various reasons. These people are, sometimes, it might just be an increased sympathetic activities. Sometimes it just is one of those things. And increased sweating has a term for it. It's called hyperhidrosis. It is often under hormonal control. And when you do not sweat, that is opposite of hyperhidrosis. That's known as anhidrosis. So hyperhidrosis is increased sweating, anhidrosis is less sweating. So let's just look at this.
Inside every hole in the body today, and our last orifice produces a substance which can sometimes be the pits. Take a look. This is like normal, and it's good to
sweat.
But it can also be stinky, especially during puberty when those hormones turn on. The bacteria on the bottom causes the odor, but then there's also pheromones, which cause action too during puberty as well. So sweat can actually be, well, it is a good thing.
As long as you don't leave it on for weeks on end.
That's right.
Then it becomes
Actually, a little bit more, yeah, deodorant.
But, you know, I came about something that is pretty interesting. A study, buttermilk, that we know is good for you. It's full of nutrients. Yes, it has some fat in it. It's healthy. But the study said that it actually may decrease sweat production.
A little
Right
buttermilk.
here. Do you like buttermilk?
I don't know that I've ever had straight up
look how
buttermilk.
thick it is. Oh my
Wow.
gosh, it's like cream. I'm not going to sweat the rest of the day.
What does it taste like?
Now let them see you sweat.
Wash it on you. You don't drink it much?
I've never had it unless it's part of.
I'm
making
Polish.
something.
We use buttermilk for.
Well, another thing you don't want to do is or that you do want to do is avoid spicy foods because that can really make you sweat, and also things like garlic, because that's just going to add to the odor.
Oh, yeah,
things
I
like
love that garlic sweat, though.
There you go.
And I want to ask you guys a question. How do you feel about antiperspirant deodorants? Because I'm going to lay this on the table. As I've gotten older in life, a lot of days I haven't been wearing it, and I haven't found that I'm.
You're still single. I wonder why. What?
No, but I want to bring this up because it's one of those things where,
No, yeah,
when I was younger, when I was a teenager, I would get home sometimes and be like, who's cutting an onion?
Yeah, right. But sometimes I like to give my body a little break from those chemicals,
And that's one of the reasons I've not been using it every day. And I say as long as you're not, smelling up the joints,
You said the
it's
closest.
probably okay to occasionally avoid it, right?
Is it okay over there?
I mean, I know it's okay, but
I'll tell you when I
if you
smell.
or people are running away from you, then you might want to use some deodorant. He's good. Oh, good.
Okay, I just thought that was interesting on little bit about, the use of these things that we use nowadays.
So did they say drink buttermilk?
Yeah, they say buttermilk helps apparently.
Probably high in calories though.
Okay, so now here let's answer some questions. In a person suffering from acne, what would you expect to find? Ooh. Okay, hyperactivity of sebaceous glands. When you have acne, it is hyperactivity of the sebaceous glands. Remember, it was infection of these glands that caused acne, okay? Not sweat glands, not because of a decreased blood supply, none of these. So it's not all of the above. It was hyperactivity of sebaceous glands. So whenever you have an all of the above, don't get it doesn't always mean that, all of those things, people tend to think whenever there's an all of the above, that's usually the right answer. So think of it, where there's a decreased blood supply, how is it going to affect your acne in that area? Yes, you had a question, Eva?
I guess what the confusion was the sebaceous gland or the oil glands, not the sweat glands. They're two separate glands.
There are two, oh yes, the sweat glands are separate and the sebaceous glands are separate, absolutely, yes. Then let's look at nails. There's not really very much in this. The cells, the top layer is keratin, and here again it is hard keratin. And when you look at the nail, this is the free edge, the one that you clip, and it's dead keratin, so that's why you don't feel any pain. This area is called the nail body, and it's, because it's present just over capillaries, and that's why you can see it's like pink in color. There is a part of the nail which is embedded inside, which is known as the nail root. And here you often have this kind of whitish area, which is called the lunula, because it is a very thick stratum basale over there. And this part is the cuticle, which we always push back when you go get your manicure done. So here again showing you the same thing. So you can see the free edge of the nail. Just below the free edge, that area is known as the hyponychium. This is the nail body. And this is sitting on a nail bed. You can see this area is the nail bed. These are the other layers of the epidermis. And this part here is the nail matrix. Again, remember matrix, which we had for the hair also. So the nail matrix is the area which is the one which is going to divide and give rise to cells. And that's how this is going to push the nail forward. So when this nail matrix divides, it keeps pushing the nail forward, and that's how the nail grows. And here, this is the cuticle, which is known as eponychium. Nychium for nail, epo meaning above and hypo meaning below. So this is the part, and again, dead cells, and you can kind of, cut it or push it back. Now, you had a question?
I was wondering, why do you push back the cuticle?
Oh, just to make the nail look a little better. They do it, the nail look a little longer. Yeah, it just makes your nail look a little longer. Yeah.
What creates the ridges on the nail?
On the surface of the nail? I'm not really sure what really does that.
I didn't know if it was like a happy.
No, it's not always. Not always. Some people have ridged nails without having any deficiency. Sometimes there is a bit of a vitamin deficiency, but sometimes maybe not. Let me find out and let you know.
When you see the waist spots too.
No, that is not. No, they say those white. No, that's nothing to do with calcium deficiency. No. So let's look at this. What is the advantage of having hard keratin in nails instead of soft keratin?
There's no all of the above there.
Goodness, glad to put that one.
Yes, very good. If you don't want your nails, do you want your nails to be peeling off all the time? You don't, right? Just as your hair, you don't want it to be peeling off. So that's why you have hard keratin over there. Not because it prevents growth of nails. Your nails do grow. You all know your nails grow. You have to clip them at least once a week, right? Okay, so here's another question. Which of the following are accessory organs of skin? So this is kind of showing you how to answer questions like this, where always choose the best answer in the lot when multiple choice. Very good, yes. Epidermis is not an accessory organ of skin. Epidermis is part of skin, as is dermis. So these two answers go off automatically. These are accessory organs, but this is the best answer because hair and nails are as well as sweat and sebaceous glands. Okay? Let's now look at some of the skin conditions. One of these is cancer. So you have some types of, different types of cancer. This is there in your notes, and I've just got 3 of the pictures. One is this basal cell carcinoma, which takes, carcinomas are usually, they're named carcinomas because they arise from epithelium. So this arises from the basal cell. It's often called a rodent ulcer, as you can see here. Least malignant. Doesn't tend to spread. Malignant, when we say malignant, it means it's dangerous, that it usually spreads. And any cancer is malignant when it tends to spread. So this one is the least malignant, doesn't tend to spread, tends to stay localized in that area. Here's another one which is called squamous cell carcinoma, made of from the squamous cells. It tends, because it is coming from the top layers, it can keratinize in certain areas. So that area might kind of look a little thick. This also doesn't spread usually. So has a good prognosis. That means, if someone has this carcinoma and it's removed, you can say, okay, you're clear and you can live for a long time. There are no more problems that you'll encounter.
That looks like it would still give you a nasty scar.
It just looks bad. Yes, the squamous cell, and you could have a bad scar in that area, yeah. This one is called a melanoma, and that's why it's known as a malignant melanoma, because this spreads by both lymphatics and the bloodstream. So both by lymphatics and blood. So it can begin in the skin and it can spread and go to distant areas, so and lodge there. So you start with a skin problem and you go elsewhere. So you really want to catch it very early. Pardon? It's the melanin pigment is what gives it this dark color, yeah. Yes. It can be really, really dark like this. That's why any moles which are very, very dark, they always like to biopsy them and, kind of rule out that there is a problem. And in order to see whether, to determine the prognosis of a cancer or to see, we have a kind of a system which we call the ABCD, and now they've added an E also, rule to determine the problem that this cancer could give or staging of a cancer. So A stands for asymmetry. So if you take a cancer, let's say this lady, and I draw a line right through the center, can you see the two sides are not symmetrical? So the more the asymmetry, the worse the staging of the cancer would be. Okay? So can you see here? So if it's an asymmetrical cancer, then you have a problem. If it's symmetrical, both sides are the same, it's okay. B stands for border. So again, in this same lady, if it was a clean border, hers, can you see the border is kind of jagged? So this is a problem. Clean borders are better than borders which are irregular. C stands for color. The more colors there are, the more dangerous it is. So, you may have somebody with a little brown, red, blue, brown, red, black. The more colors there are, there's more activity going on, and the more the prognosis is worse. D is for the diameter of the lesion. So this is how we would stage the lesions. D is the diameter. Anything more than 6 millimeters, you're always worried about. So in her case, this lady's case, it's really large. 6 millimeters is like the top of a, on your pencil eraser, yeah. Anything more than that, you're worried about. You always want to remove and, study that. And I remember I said we also have an E. Has been added. E is for elevation. So if the lesion is raised above the surface of the skin, that's not a good sign. If the lesion is flat, sometimes you might just have a little sort of a discoloration on the surface of your skin, and that's not raised, that's okay, that's less problematic. So these are how we stage the lesions and determine whether it's the lesion is dangerous or not. So asymmetry is not good. Irregular border is not good. More colors there are, the more dangerous it is. The diameter is more than 6 millimeters, you're always worried. If it's elevated above the surface, again, you don't like that. That's not a good sign. We have other conditions which you have in your notes. One is called a turban tumor. Some believe it to be epithelial in type. Some believe it to be blood vessels which are kind of formed in a different way. So it actually forms a huge tumor which sits on the top of your skull like a turban. And then you may have often seen people with birthmarks, and these are known as nevi. And I have again a picture in your notes. Take a look at that. These birthmarks are usually due to blood vessels which are present under the skin. Those blood vessels kind of have developed in a little haphazard way, and they give rise to these birthmarks. As the child grows, most of the time they tend to kind of get erased. They disappear. Sometimes they may remain, And then, the person may have a permanent birthmark, or they might decide to do some plastic surgery and have it removed. Okay? So you can see a strawberry. Sometimes people have this reddish discoloration, usually on the face or anywhere, and we call it a strawberry nevus. You had a question?
I have a blue one.
Yeah, you have a blue one? Yeah, it could be any color, usually, reddish or bluish, and it just doesn't disappear in some people. Then lastly, let's look at burns. So just a brief description of burns. So burns could be any type. Usually when you think of burns, you think of just sort of burning yourself with heat, but it could be just scalding with moist heat. It could be an electrical burn. So we divide burns into basically 3 degrees. As the picture shows here, the first degree is where it just involves the epidermis. So the first degree burn involves just the epidermis. And usually you'll see the area being red, erythema. You'll see that redness or erythema. Normal sunburn is a good idea of first degree burn. Second degree burn, notice, it involves both the epidermis and part of the dermis. And usually you'll see these blisters form. So notice here, blister formation is very common in second degree burns because it involves the dermis, and usually a little bit of separation between epidermis and dermis occurs and fluid gathers there, and that leads to blisters. In both these, because nerve endings get exposed, the nerve endings which are present in the dermis, they get exposed. Both these burns are extremely painful. Third degree burns are ones which involve the epidermis and all of the dermis. In fact, they may go down to involve the lower tissues, the hypodermis, the muscle and bone. In fact, some people even call that fourth degree. But it involves all of the epidermis and the dermis. So it's not painful because the nerve endings have also been disrupted. Blood supply also goes. And usually you can see here the area kind of looks really black and charred, or might be very grayish looking like here in this area. These are really terrible burns to sustain. And when anyone sustains a burn, especially, second degree and third degree, in the first degree burns, because the epidermis is removed, it can regenerate. But anyway, whatever kind of burn you have, this protective covering is gone. So then infection can set in. So you're always worried about infection. Also remember, one of the functions of skin was to prevent fluid loss. Now the skin is removed, so fluid loss could occur. So you're always worried about 2 main things, fluid loss and infection, because a person could get dehydrated. The greater the surface area burnt, the more the fluid loss. And we in fact have something known as the rule of 9s, where, we divide the body part into by 9s, like for example, your thorax, the front is 9% in percentages. So take a look in your book, it kind of divides that just to get an idea of that. So let's look at this little video which describes burns in a little bit more detail. They're not painful. Third degree are not painful. Yeah. But they're most dangerous because you have so much tissue loss.
Burns are skin injuries caused by heat, chemicals, electricity, or radiation. Your doctor will recommend treatment based on the size of your burn and the layers of skin the burn affects. Your skin has 3 main layers, the dermis and the hypodermis, or subcutaneous layer, vessels, and nerves. Beneath the skin are tissues such as muscle, fascia. First degree or superficial burns affect only your. The burn site appears red and dry with no blister and is mildly painful. Second degree or partial thickness burns involve the dermis and portions of your upper dermis, and lower dermis. The burn site is red and moist, blistered, swollen, and very painful. Degree or full thickness burns extend through your dermis and into the hypodermis. The bite appears patchy in color, ranging from white to brown, with high leather texture. Because the burn is so deep, it causes little or no pain. Fourth-degree burns involve the destruction of all layers of your skin, sometimes extending into the underlying soul or bone. These burns are brown, dry, charred, painless. You can treat your first-degree burn by soaking it in cool water. To soothe the tissue, apply an antibiotic ointment and cover with a clean, dry bandage. You can take acetaminophen or ibuprofen for pain. Care for a second-degree burn by soaking in cool water for several minutes. Apply an antibiotic ointment to prevent infection and cover with a clean, dry, non-stick bandage. Change your bandage every day and make sure your hands are clean. Acetaminophen or ibuprofen may help with pain and swelling. If you have a third or fourth-degree burn, go immediately to an emergency department. If you can, elevate the burned body part higher than your heart. You will also need to seek medical attention if your burn is larger than 3 inches in diameter, or if it is located on your face, hands, feet, groin, buttocks, or over a major joint.
And remember, she said third-degree burns we call full-thickness burns because it involves the entire thickness of skin. The first and second are also known as partial thickness burns. So these are called partial thickness, and these are known as full-thickness burns.